This is the solution to Chapter 14, Video Assignment 1. The question states, in a 1985 study of a lake in Wisconsin, the locus called Little Rock Lake, Wisconsin, 400 gallons of 18 molar sulfuric acid were added to the lake over 6 years. The initial pH of the lake was 6.1, and the pH at the end of the lake, at the end of the study was 4.7. Assume that none of the acid was lost, that is, every mole of sulfate added in those 400 gallons was still there at the end. What is the volume in liters of the Little Rock Lake in Wisconsin? So using the information that is given to us, we have the pH, we have the volume, and we have obviously the compound sulfuric acid, we can determine the volume of the lake. So first off, it gives us the volume added in gallons. We need to just take that to liters so we can work with it. So simple unit conversion, 400 gallons times 3.78541 liters yields 1,514.16 liters of sulfuric acid were added. And it gives us the molarity as well, which is 18 molar. So using the molarity and the volume, we can determine how many moles of sulfuric acid were added to the lake. So 18 moles per liter times 1,514.16 liters yields 27,254.88 moles of sulfuric acid were added to the lake over the 6 years. Now, sulfuric acid is a polyprotic acid, so it's got 2 hydrogens, and for the purpose of this question, we'll just assume that it dissociates fully. Both of the hydrogens come off of the sulfuric acid when it dissociates. So it reacts with water according to this equation. H2SO4 plus H2O yields hydrogen sulfate ions and hydronium ions. And hydrogen sulfate reacts with water according to this equation. HSO4 minus plus H2O yields sulfate, SO4 minus, and hydronium ions. So using these 2 empirical formulas here, we can determine that for every mole of sulfuric acid that is added to the lake, 2 moles of hydronium are produced. So our 27,254.88 moles of sulfuric acid, we multiply that by 2 to determine 54,509.76 moles of hydronium were added to the lake over the 6 years. So now, the other important bit of information we have is the pH at the beginning and the pH at the end. So the formula for pH is minus log of the hydronium concentration. We can rearrange that to solve for hydronium concentration, which is, of course, molarity here equals 10 to the minus pH. So for our initial concentration, we have hydronium equals 10 to the minus 6.1, the pH was 6.1, which gives us a value of 7.94 times 10 to the minus 7 molar. For final here, we've got concentration hydronium final equals 10 to the minus 4.7, because the pH was 4.7, which yields 1.9453 times 10 to the minus 5 molar. So if we just think about what these numbers represent, really we can see this as moles per liter, right? So for every liter of lake, there is 7.94 times 10 to the minus 7 moles. So this is how many moles are in each liter at the beginning, and this is how many moles are in each liter at the end. So if we think about this, we can just subtract the initial molarity minus the final molarity, and we'll see how many moles were added per each liter over the duration of time. So delta M here, just changing molarity, 1.9453 times 10 to the minus 5 molar of the final, minus 7.94 times 10 to the minus 7 molar for the initial, equals 1.9159 times 10 to the minus 5 molar. So this many moles per liter is how much the change was over the course of the 6 years. So if we have how much each liter changed in moles, and we have the total number of moles that were added, we can simply multiply those 2 values. Well, the reciprocal of this, right? 1 liter per that many moles. So 1 liter per 1.9159 times 10 to the minus 5 moles times the total number of moles, 54,509.76. Those units cancel, leaves us with 2.85 times 10 to the 9th liters of volume for the lake.